if you change your top plate, rather than stop, it's moving. When you have that, don't get nervous, don't get shiver. Okay, it's nothing. If you look at the condition now, the only changes is the boundary condition. Now the boundary condition, rather than having u equal to 0 at y equal to h, you have u equal to big U at y equal to h. Clear? So that's the only difference. Because if you look at how I cancel the term, it's exactly the same. I cancel this one because we are talking about steady incompressible flow, right? I cancel this because it is steady flow. I cancel phi because phi is 0. I cancel w because w is 0. I cancel du dx because from my continuity equation, I found that du dx is equal to 0. Which means u is not a function of x. It's only a function of y. Any question? Okay, do you understand? I have to change my question. Are you okay with it? Or am I going too fast? Going too slow? You repeat too much. Right. Let me know if I repeat too much. Okay, now you see this one is exactly the same with what you have before, right? Now the only difference is, see, this one is also the same. The only difference you can see in the boundary condition number 2. In the boundary condition number 2, rather than having y equal to h, u equal to 0, now you have u equal to u. Okay. I know some of you do not like to have a symbol. Don't worry. Like in your tutorial, you know that u is some value. It is some number. So you don't have to worry about it. Okay. At the moment, I do not want to give a number, so I put u, just big U. Right? But it is just a number at the end of the day, right? Okay. Now, if you look at the boundary condition number 1, since the condition is the same, you can be sure that the final answer will be the same. C2 will be 0. Right? Because you know that at y equal to 0, u is equal to 0, so you plug in. U is equal to 0 when y is equal to 0, so you get C2 is 0. Is that clear until this point? Okay. Now, the problem comes from the next one. U is equal to big U when y is equal to, okay, in this case I'm using B so that you don't get too excited with the H, right? H is handsome, B is beauty, so it's the same. I mean, you can give whatever you want. You can put C there also. It doesn't really matter. You can put cat there as long as you're consistent. It's okay, right? But in this case, I just change it from H to B. Okay. So now the only difference is previously, since this one is 0. When you move this one to that, there is nothing there, right? 0. So you have only one term. Now, since this one is no more 0, you will get additional terms. Now you get U over B. Where this one comes from, you can see this one, I move to there, it become U minus this big chunk, right? This big chunk now is moving to that direction. Now you have C1B. I do not want C1B, I want C1. So you divide those with B, which means you will get B squared divided by B give you B. U divided by B give you U over B. Is that clear?
Yes.
Okay, now you have C1, you need to plug it back to that C1. So you replace that C1 with this thing, you will get this. So don't worry about the second part. I don't need you to do that. Just remember this. So if you have C1, you get this. Okay? Don't remember this one. Actually, you need to know how to get it. Because that one can change. And by now you know that I would love to change that one. Right? I may change that. U is equal to minus U when Y is equal to 0. So you should know how to do it. Okay? You rather remember how to get it than what is the final answer. Okay? You rather remember how to get the money rather than remember the number of the money. Because the money in your hand will change. Okay? So that's the thing. I can change the flow, I can change the flow condition, but as long as you understand how to analyze it, should be no problem for you. Okay? Yeah? We will try it during the tutorial. Okay? This week, we just finished question number 1 and question number 2. So next week, we'll still have question number 3 and question number 4. Question number 5, you try on your own. I give you the solution there, so you can try. Any question until now? Okay, I wish to skip this one because it gives you a lot of confusion later on. So you don't have to worry about this thing, you just play around with it. The only thing that you need to understand is how to get this one. Okay, once you get this, you can find your Umax, you can find your flow rate, you can find your, what else? Shear stress, anything. Because the concept is the same. If you have no question, please go through the problem example on your own. If you have any question, any problem, as I told you, you are free to ask during the class or during the tutorial, or you can come to my office, but please make an appointment first. Okay? The problem example, usually I will explain detail, but since the step is quite detailed in the slide, so hopefully you can try to go through on your own. Okay? And if you have any question, feel free to ask me. Okay? So this is problem example for flow scenario number 2. Okay. Now, if you allow me, if you are ready, we can change a little bit our flow scenario by having flow scenario number 3. So in this flow scenario number 3, there is 2 big changes that I will introduce. Okay. First is the changes on the direction of the flow. Right. In the first flow, you have the flow in a nice flat plate parallel like this, and you got this one your y and this one your x, right? By having so, you nicely have only u because there is no other flow, right? Now you have this. If you love too much with your coordinate and you let it do like that, what will happen is okay, you love this x and y so much in this position, okay? You are too familiar with it, alright? So this is your coordinate. What will happen is, now your flow is going to this direction. This is your flow, which means you will have u, velocity in the x component, and v, velocity in the y component, because now the flow is going to that direction. Remember, like this one, in this room, we already said, okay, this one is my x, sorry, this one is my x, that one is my y, and that one is my z. We do not want to change it. Now the flow is changing that way. Now, since it's moving that way, which means it has velocity in the z component, and it has velocity in the x component. Do you want to do that? if I were you, I do not want to complicate my life. My life is complicated enough. So what I will do is I will just change this thing. Now you have to follow me. It has to be like that. X and Y. Okay? Any one of you want to use this one? It's up to you. I mean, so long you know how to solve it, I'm okay with that. Okay? But in this case, I will follow this. Okay? So with this, what happened is I still nicely get only U. I do not have any phi. Which means my phi and W is still 0. Lovely. Because then I know I can solve it. Right? Because if it has U and phi, I don't know how to solve it. I know how to solve it. I will ask my student to put it in the fluent and solve it. It's easiest way to do that. But analytically it will be quite tough. You may need to put some perturbation method to segregate between U and V, right? Doing some integration by part to solve it. Then you can solve it. Okay? Some of you may want to do that, but not me. Okay, that's one thing. So you change the geometry. Now, the boundary condition. Do you realize something is missing there? Because a fluid just trickling down the plate, just like this, which means this fluid got no top wall. There is no top wall. Free surface means there is no top wall. It's like you go to the river, okay, you see the river flowing, there is nothing on top. Actually, scientifically, there is air. So you cannot say on top of the river there is nothing. No, scientifically it is air there. So air is there. Okay, like now, scientifically, air is surrounding you. Unless you put yourself in a vacuum chamber and you suck the air, then you will have no air accompany you anymore, right? But everywhere air is there. So in this case, you can see that actually there is an air, free surface.